Geotechnical Engineering Part A, Soil Mechanics Session 9, Air Percentage Calculation. In this example, we are reviewing an interesting problem in calculation of air percentage and also moisture content. So if the data are provided to be total mass of 35 gram of our sample and specific gravity is provided to be 2.65, we want to calculate the part A air percentage and at the same in part B moisture content of our sample. Mhm. So in the first part we put our soil sample in a water. Mhm. And in the second part, and it just rise up by a height of 1.6 centimeters. And in a second case, we just replace our sample in a highly viscous oil. And in that case, it just rise by 1.9 centimeters. So we want to know in part A what is the air percentage. So in calculation of air percentage, so just consider we put our sample in scenario 1 in just water, and it just rise by a height of 1.6 centimeters. And in second case, we just relocate our soil sample with three components of soil, water, and air in a very highly viscous oil. So, and it just rise by 1.9 centimeters. We want to calculate air percentage for these problems. So, air percentage is volume of air over total volume. Mhm. And in case one, for example, if we call it case one and case two in water, when we relocate our sample, soil sample in just water, it's just 1.6 centimeters height rise and times the area of the base, which is a 10 centimeter squared, and that's 16 centimeter cubed, which is 16 cc in terms of volume, and 16 cc is equal to volume of soil plus volume of W, volume of water. So in this case, because we just put it in water, the water fills all the void, so there is no air entrapped in the sample. So we just have volume of soil plus volume of water, and that's equal to a total of 16 cc. And in highly viscous oil, it's just something like we are a kind of protecting our soil sample with a highly viscous oil. In such case, we have volume air, volume water, and volume soil. All three of them are available because the oil is something like a protection layer, develop a protection layer all around the sample. So there is no way to it just work like a isolation layer, and it just have all these three component of soil sample. So in this case, the rise in elevation goes by both three components. So that's something like for volume of soil, volume of water, and then volume of air, entrapped air in the isolated layer. And again, the area is the same, so 19 cc is including all three components. That's the keynote of the problem. In oil, in scenario one, which we have water, water will fill the air part of the sample one, but in second condition, water or oil cannot fill that part because it just uh, develop a protection layer or isolation layer around all around the sample. So in such case, let's make it a bit clean. In such case, if you subtract scenario 2 minus 1, which is, it just gives us the only difference is volume of air, which is entrapped in the isolated layer. So VA is 19 minus 16. 19 minus 16 gives us a numeric value of 3 cc. Mhm. And if you just divide the for air percentage volume of air over total volume, so just go for the second sample, total volume is 19, which is here 19. A 3 over 19 gives us air percentage of 15.8, almost 16 percentage of air. In part B, we want to calculate the moisture content, and this part is pretty interesting too. This problem is a kind of interesting problem in soil uh, weight volume relation. So from the first part, we do have volume of soil plus volume of water is equal to 16 cc. And we do know if we rewrite the moisture content, we are looking for moisture content base of volume, it's 1 over GS times volume of water over volume of soil. So, and at the same time, we do know rho density is mass over volume. So if we rearrange the equation based off volume, it just gives us volume is equal to mass over density. And so base off of this equation, we do know volume of solid plus volume of water from the first sample is 16. So mass of soil over rho of soil, that's a Vs plus mw over rho w, that's EW is equal to 16. We just rearrange it in different format based off their volume and mass. And at the same time, we do know Ms mass of soil is equal to total mass over 1 plus moisture content W, and M of mass of water is equal to W times moisture content and mass of uh, total mass over 1 plus W. So, and at the same time, we do know gamma S is GS times gamma W if we just rewrite it based off density, not a specific weight, not unit weight. This is unit weight. This is density. Rho S is likewise GS specific gravity times, this time not gamma W, just rho W. And if we replace that in this equation, so all this plus, let's make it a bit clean, all this equation plus star, it just, if you just replace the numeric value ms from the problem data statement, it's provided to be 35 gram over 1 plus w, 1 plus w gs rho w, that's just this part ms over rho s, and ms is mt plus 1 plus w, over rho s, and we just replace this part and this part in the equation, plus a mw, that is the moisture content times mt over 1 plus w. I think it should be w times 35. So the summation of them should be equal to numeric value of 16. So if we just, yes, that was correct, 35 plus 35w. If we just rewrite the equation in whole and just replace the numeric value and just take this part, so GS is provided to be 2.65 in problem statement, And if we just take this part out of them and bring it here. So that means 35 over 265 plus 35W and is equal to, just take this part all in the second part. So that's 16 times rho W is equal to 1 gram per centimeter cubed plus a moisture content W. And if you just do the math, it just just make it clean, gives you this equation based off W moisture content. And if you solve the equation, it just gives us a moisture content for this problem is equal to almost 14.7, almost 15%. We'll solve more problems. Thank you.